And welcome to the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. We ain't got no new space weather on the way, but we certainly got some new fresh footage of the closest star for you. It's always the most interesting one to view, the one around which the planet on which you reside orbits. These are 24-hour videos at 30 frames per second from Solar Dynamics Observatory. And there have been some CMEs. They just aren't earthly directed. So we do have a very high likelihood of large solar flares. And there are two main locations to keep an eye on. And when I say eye on, pardon the pun. So we have a fleeting likelihood of large solar flares on that western limb. That's going to expire within the next about 12 hours, as those sunspot groups will be a little bit too far behind the limb to be likely to produce flares. So that likelihood will be dropping here in about 12 hours down to just about zilch. However, in the southeast, we have quite a chaotic sunspot. We have some unstable looking plasma filaments, and it is a sunspot that has come back once again. So that is really where the action is. That is our TMAS for the day, the most active sunspot. And don't worry, we've got plenty more coverage for you here. By the way, if you enjoy the content, don't forget to press the like button. Tell your friends and foes by pressing share. Hit us up on social media. Thanks to everybody who has discovered the channel's existence. And if you're new, of course, press the subscribe button. Otherwise, how would you receive the world's most comprehensive daily space weather content and most detailed solar imagery right in your inbox? Let's do a quote. Do one thing every day that scares you. Why is this? Because the learning curve when you are a noob is very steep indeed. So be a noob, get out of your comfort zone, learn a new skill, go do the thing that you're bad at. Yeah, go do the thing that you're bad at. Learn how to write opposite-handed. Are you able to write with your non-proficient hand? That's a skill that you'll improve on very quickly. So anyway, do something every day. Do one thing every day that scares you. The things that you're the worst at are the things that you'll most rapidly get better at. Back to space weather stats, the radio flux, the 10.7 centimeter radio flux, that is, otherwise sometimes referred to as the F107, is at 196 solar flux units. So that's flat from yesterday. That's, I think, exactly the same as it was yesterday. We had a bunch of setting sunspots and a bunch of rising sunspots, and the radio flux has just remained level. That's the past year, as conveniently reported by Solon.info by that black line. You can see higher lows continue to happen on the radio flux. Now, like I said, no new space weather on the way. NOAA agrees, and so does ESA. So we won't spend a lot of time looking at that. Space weather has been mild. And again, there are no new CMEs or coronal hole high-speed streams likely to be on their way to Earth. So here are the past 4 hours of Earth's magnetic moment from space, and it is very calm, very geomagnetically calm at the moment. So you'll be unlikely to see the aurora at mid-latitudes and so forth. So sorry, aurora chasers, but you'll only be likely to see the aurora in the normal locations, places like Scotland, Iceland, Greenland, etc. So that's the past 4 hours of Earth's magnetic moment from space. Next is our ground magnetic perturbations map. This depicts magnetic flux density at the ground level. And if you haven't pressed the like button, press the like button, lest thy soul be cast into an ever-deepening and darkening abyss of terribly ridiculous YouTube content. KP index, an average of global geomagnetism, is currently at 1. KP1 is the calm condition. And here is our solar wind data. It's slow and low. That is the tempo. So it's diffuse at only 2.18 protons per cubic centimeter, at least at ACE, and barely over 300 kilometers per second at Discover. A little bit denser and similarly slow. So 5.5 protons per cubic centimeter there at Discover. Only 306 kilometers per second. Our GOES magnetometers here are pretty smooth. So the magnetic fields in the outer Van Allen belts are pretty nominal at the moment. Next, heliosphere magnetism. And Earth has been in a North Pole-oriented sector, and it looks like that will still be the case by the time we do tomorrow's Daily Space Weather video. And by the way, did you know these videos are going to come back to the morning, most likely? Yeah, the videos are going to come back to the morning. So, yeah, that's another little change happening to the channel, likely soon. Next, our line of sight field plot depicting a whole lot of information over the past 4 days. Solar B field here depicted in blue. Polar fields in red and green for south and north respectively, and then you've got the photosphere magnetism in grayscale, basically showing you all the solar magnetism in one convenient series of frames. That's 115 frames, which brings us to coronal holes. You can expect to see mostly North Pole oriented coronal holes, but they are not well defined. So at the moment, coronal holes are looking pretty weak. So let's cut to the SDO imagery at 211 angstroms. There you go. That's what's been going on for the past 24 hours. Coronal holes pretty uneventful for today. Getting back to some more solar data. Sunspot number here still over 150. It's at like 152. I'll say 152 sunspots is the current number. Next, our flare probability monitor here. And they've made some changes to the Integrated Space Weather Analysis Center, so you may have a little bit of a learning curve there if you decide to use the ISWA, the Integrated Space Weather Analysis Center of NASA. So the current situation is very high likelihood of large solar flares, especially in that southeastern limb. That's going to be the most likely spot for a large flare moving forward. And let's take a look at sunspot names here. How do I, does it, oh, you got to press stop now? Okay. So, yeah, we do have new sunspots that have names. Let's take a look at the SDO data page. And there's the magnetogram complete with sunspot names. So let's see. The next active region will be known as 3727, as we have a number of new named sunspot groups down there in that southeast. Also, one in the northeast, too. That's, yeah, so we have a little bit of growth here of these eastern sunspots, but it's been pretty minor. And by the way, little side note about sunspots. We put out a video today, one of our Ask a Particle Physicist segments. It's actually segment 26. I have to edit the name. And it is about active solar longitudes. Yeah, active solar longitudes. So if you check out our playlists, if you click the View Full playlist, scroll down to the bottom, there you go. There's the latest heliographic active longitudes betray internal structure. So let's play a little teaser from that.
In your studies of sunspots, you noted that there are certain locations.
So it's pretty interesting that there are two locations that are 180 degrees away from each other that produce more sunspots than all the rest of the portions of the sun. So that's a video to check out. And let us know if you have theories about why this would be. Is there some sort of an internal rigid structure in the sun? And if so, doesn't that sort of defy the common knowledge about heliophysics? Anyway, again, you can find that in our playlists. Let's take a look at sunspots here from SDO's perspective. So here is our custom 24-hour animation, and we're just going to zoom way in on the most active sunspot down there. Which again is known as 3723 on this time around. 3723 is the T-mass. It did produce a nearly X-class event yesterday. So there's a great view of that. We rotated the field of view here to keep that sort of stationary on screen. And here's the magnetogram. It does look like it's beta gamma delta class, just barely. It's not super chaotic looking, but it is quite irregular in terms of its field symmetry. It doesn't really have any field symmetry. So anyway, moving on to energetic particles and flares. And we did have a little bit of a minor uptick there in the proton flux, so that's not enough to really cause any polar radio blackouts or anything like that, but we do see a little action there. So that's likely caused by activity setting in that western limb. And here's that flare we mentioned earlier. It was right around 1300 Universal Time, an M9.3. So not half bad. And also the background flux here got all the way up to an M-class level for a minute. So that's pretty interesting. And let's take a look at our 131 angstroms wavelength. Excellent at showing flares. And we'll zoom way in on that sunspot 3723. It is the place to watch. We've also got the 94 angstroms wavelength for that. And there is that 94 angstroms wavelength. So yeah, sunspot 3723 is our T-mass moving forward, the most active sunspot. And that footage is not bad. Not bad. Next, we'll do a solar system forecast, and then we'll get to CMEs. Yeah, CMEs, coronal mass ejections. Oh, and by the way, here's that M9 class solar flare from yesterday in 94 angstroms. M9.3, I think it was. So that's a pretty decent sized solar flare there, with perhaps more to come. I guess we can animate that briefly for you here. Here we go. So that's what's going on, and here comes your solar system forecast. This is 7 days in the future. Let's try that again. 1, 2, 3, 4, 5, 6, 7. There we go. That's where things will be on July 1st in the solar system. This is where things are when we shot the video. It's currently 4:50 p.m. Eastern Time. We've got a setting Jupiter, and of course Venus and Mercury trailing the sun there across the ecliptic. Before we get to CMEs, the most distant object, at least according to redshift estimations, ever. It's Jada's GS Z14-0, believed to be something like 16 billion light years away. That's pretty decent distance. And yeah, it's the James Webb Space Telescope has imaged that cigar-shaped galaxy. It's a little bit blurry, as those photons have had to travel quite a distance. Anyway, moving on to CMEs. Here are today's events to date. One major CME there out of the southwest. So there they are on the LASCO C2 and C3. We'll also show stereo A, which is located where that red dot is. That red dot right there. Stereo A giving us a little bit better angle. A little bit additional angle there. And I can barely reach the controls. Let me see if I can. So there's that CME. It does not appear to have any earthly directed components. It will miss to the south and to the west. Also Venus appearing in that imagery. And here come our custom coronagraphs. That's a 24-hour video for you. Just reinforcing the fact that there's no new space weather on the way. Not a bad light show, though. Now, we do have some extremely volatile plasma filaments. In fact, Yeah, there's quite a lot of volatility going on. I mean, you're going to see a lot of plasma motions on the Earth side of the disk. If you look at that, that's in the center there, the SDO imagery, that's the 193 angstrom 60-minute running difference along with the 304 angstroms. And yeah, look at the filamentary motions. We've got a lot of volatile filaments. So likelihood of CMEs going into tomorrow, once again, is 99.9%. There are going to be more CMEs in the next 24 hours. It's pretty much guaranteed, give or take a tiny, tiny fraction of a percent. So that's the scenario, and we're going to come back to filaments to close out the video here with our custom filamentary imagery. First, some more. Here is a Big Bear viewing hydrogen alpha. That's great at showing filaments. And you're going to see that one in the north vanish. So that one is, you could have named it, but now it's gone. So quite a few filaments there. Here's the grayscale imagery. We show it because it shows prominences. And the prominence scenario isn't really too crazy right now. Before we get the bonus features here, the past couple of hours from the GO 16 SUVI. You can see a little bit of flaring there up in the northwest. Notice the plasma volatility down there in the southeast. So you'll see motions down in here. You'll see motions down here in the southwest. Also, this filament here has been looking very volatile over the past 24 hours. So that one could blast off too. Anyway, here come bonus features. Starting with satellite charging hazards, we ain't got none. It's smooth sailing. Electron flux here coming off of its lows, but still kind of low. There's a forecast model by NOAA. No qualms from me there. Here is our ionosphere map. We show this diagram so that people are familiar with the altitudes of atmospheric layers, the temperatures of atmospheric layers, the penetration of electromagnetic radiation, and finally chemical concentrations. Here is our ionosphere map. And things are looking very normal, at least with respect to the 30-day average. Remember, folks, around times of the solstice, we get the least likelihood of geomagnetic storms. So, in other words, you have to see a stronger magnetic storm impact in order to actually see the effects from it because of the lack of the Russell-McFerrin effect, which is when high-energy electrons are accelerated in the outer Van Allen belts. So here's the anomaly in megahertz from a 30-day median. Again, things are quite normal here. I would note briefly once again that the South Atlantic anomaly has moved to the South American coastline at 45 degrees west longitude. So you see that 45-degree line, you follow that up to the South American coast. The South Atlantic anomaly is right there now, as opposed to in the middle of the continent. No, that doesn't spell doomsday, if you're wondering. If you're wondering what's going to end civilization, the answer is probably nothing. You'll have to have a mechanism to come up with that extraordinary claim. In other words, you'll need extraordinary evidence. So here's our Global Ionosphere Nowcast, or WAM, the whole atmosphere model. GPS users pay attention to the left. And radio users pay attention to the right. Or don't. It's not going to hurt my feelings either way. But that's what's going on in terms of space weather versus your use of technology. And we'll close out here in just a moment with the latest high-res images. So let's see what's going on with these groups. Got a whole bunch of sunspot groups there on the screen at once, which is always nice. There we are. So those are beta, gamma, delta sunspots there in the southeast. Most of the rest are pretty simple, though. So not too exciting, and like I said, no new space weather on the way. So filaments will remain the story here moving forward. Again, the likelihood of coronal mass ejections is just this side of 100% the next 24 hours. You'll see quite a lot of plasma instability there. I'll just leave that on the screen for a minute so we can reflect on that. And in the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.